Okay.
Welcome everyone to a special Grazing Club Zoom call with John Stika on March 12th, 2026. I sent John an email. I had been meaning to do it, and then I don't know, just kept putting it off, and sent him an email back maybe a couple weeks ago, and he probably called me within 20 minutes of the email going. So that was pretty cool. And we talked for over an hour. And so John was nice enough to agree to come on and talk about soil health and regenerative ag. And if anyone hasn't read his book, A Soil Owner's Manual, highly recommended. Get a copy, get the audio book and read it or listen to it 10 times, and then maybe you'll get half of it, or at least I'm a slow learner. But that little book is just jam-packed with good stuff. And I spoke with a group of second year ag diploma students yesterday, and I recommended that book to the students as if they're interested in soil health, that's the a good one to start with. So anyways, we have John here today. He's got a little bit of a presentation to start with, but this is more, chance to ask good questions, have a discussion. So if you have a question, probably best just to ask it in the moment. And if you're not comfortable with that, just throw it in the chat, and I can monitor and ask questions as we go. And then there'll be chance at the end for more discussion and Q&A. So welcome, John. Thanks for coming on Zoom with us today.
Oh, thanks, Michael. I can I can talk about this stuff all day, but I threw a few slides together just to kind of cover a little bit of the basics, just to kind of get our head in the space of soil health. So I usually start out with, what is soil health and why should we care? Why should anybody care? And you'll hear me talk about soil function, and soil health is no different than our own health in that if you go to a healthcare professional, the whole thing is, how are you doing today? How are you functioning today? And then you go from there. Well, I'm having a problem with my arm, or whatever the case is, you're not functioning as well as you could be. So the idea is then to restore you to full health so that you're functioning again. And so I look at the soil the same way, and instead of just looking at one organism like ourselves, there's a whole community of organisms that live in the soil that need to be fed. They need to have cover. They need to have water. They're no different than any other animal that has habitat, food, water, shelter. So we just need to think microscopically, because most of them are microscopic. We just need to think that way about how do we create this ideal habitat in the soil so that these organisms can thrive and do all the things that we expect the soil to do. We expect the soil to infiltrate water and supply nutrients to plants and on any number of other ecosystem services. But we too often have been looking at degraded soil for so long that we think that that's normal when it's not, and that we need to restore that capacity of the soil to do all of these things. And once we do, it's pretty amazing what the soil can do, how it can infiltrate a big rainstorm, how it can supply all the nutrients to our plants, all these other things that it's designed to do. But too much of the time, we're in the way with how we're managing the soil that's making this habitat less favorable than it should be. So that's a little bit of the background on that. And then I came up with these four principles uh, right after I retired from USDA. And I was talking about some of these things with a few folks, and someone looked at me and says, "Have you written all this down?" And I said, "Well, it's scattered around and all kinds of other stuff." So I decided, well, I'll write a book and I'll put it all in a book so that it's all in one place and make it approachable so anybody can look at what these four principles are. And these four principles focus on making this favorable habitat in the soil for the soil microbiome. So we want to disturb the soil as little as possible, whether it's tillage, whether it's applying fertilizer or pesticide or something that's going to disrupt either the structure of the soil that these organisms live in, or it's going to kill off some of them, or it's going to disrupt the relationship that these organisms should have with the plants. Those are all things that are very disruptive to this whole microbiome. To maximize the diversity of the plants that we have in our rotation or cover crops, and this is probably one that holds people back the longest. If you go out on native prairie in Manitoba, there's over 100 plants out there. There's over 100 species of plants out there. And that's how nature set this up to work. That's the level of diversity that nature is expecting to have in a system. So if we have a crop rotation with only 2 or 3 crops, that's not very much diversity when you consider the level of diversity that the soil is really expecting in order to be able to function. And that ties right in with the next one, to keep living roots in the soil as much as possible, because that's how these organisms get fed. Plants will do photosynthesis and make sugars, and they'll share sometimes half of the sugars that they make. They'll share with the organisms in the soil. They'll feed them so that those organisms then feed the plants back with nitrogen, phosphorus. They'll even bring them water, things like that. So the more of the time we can have living roots in the soil, the more of the time those organisms are fed, the better job they can do. If they're not fed, in a lot of cases, they'll go dormant. So they're still there. They're typically not dead, but they'll go dormant, and so they're really not doing anything for us. And then the last one is to keep the soil covered, because we can have very stable soil aggregates that'll be stable when they get wet, but they won't be stable if they get wet and they get pounded by raindrops. So they're strong enough to hold together to allow water to infiltrate the soil. But if they start taking a beating, they may start to collapse, and then it seals things off and the water isn't able to infiltrate the soil. So that's where the cover comes in. It's also about 15-20% of the organisms that should be living in a soil food web, soil microbiome, live at the surface of the soil. but they only live at the surface of the soil if they have cover, if they have some protection. They aren't going to be there just on bare, dry soil. Life is very difficult for them in that setting. So to have residue cover on the soil allows them to do their part. So you miss out on that part if you don't have cover on the soil. So so that's soil health, and those are the principles. And when I was visiting with Michael earlier, um, we were talking about some of the persistent limiting factors to improving soil health. And I told him there's folks that have eliminated or reduced tillage and are keeping cover on the soil, but they don't have living roots in the soil enough of the time. And I think even more importantly, they don't have enough plant diversity in their crop rotation or cover crops or whatever they're growing. So so that's something we can kick around a little bit. The other thing that's kind of up and coming is nutrient density, where we're beginning to realize that without a very complete and capable soil microbiome, the plants aren't able, and typically annual plants aren't able to make the highest, biggest molecules that they should be making. They're often referred to as phytonutrients because they're very large molecules, and it takes time and it takes a fair amount of work by the plant to build those. And it's those phytonutrients that oftentimes suppress or repel insect pests, but they're the same compounds that give us the nutrition that we need. And most of them are very aromatic, so you can smell them. Animals that are grazing those plants can smell them and favor them because they know that they're going to get more nutrition from those plants. The other one was biological soil amendments and where they might fit, or how effective they might be. And then another one was grazing, integrating grazing into a system. And it's not an essential thing, but it can be another tool. So if anybody has any one of those points that they'd like to dig into or something else
Yeah.
pops in here.
Yeah, we can, if there's a question on the first slide about the principles, or maybe we
This
can,
one,
yeah.
okay.
It's yeah, I guess part of how I try to explain it is to just understand what a principle is. Like we talk about these sort of principles of soil health or principles of investing or you know on and on, and to me it's just as best as we understand how nature functions.
And I consider a principle as I came up with this list. I started out with 8 or 10 things, and I started to look at, all right, what things can I lump together? Well, it really wasn't lumping them together. It was which ones are saying the same thing.
Right.
And then I came down to okay, a principle is going to be something that must happen. We can't leave it out. If we don't minimize disturbance, we're just not going to get there. If we don't maximize diversity, we're just not going to get there. It's not going to happen.
Right.
So,
I
so
like that.
these so these are, the essential things that, and if you think of your own system and these four principles, you can zero in pretty quickly on where you could improve. You say, well, I'm not doing any disturbance. I got good cover, but boy, I'm only growing a couple different plants. That's not enough diversity. That's what's holding me back. So that's how I like to use these four principles as ways for people to examine what they're doing and what could be improved, what things are holding them back. Because the idea is to create this most favorable habitat. And like I mentioned, with any animal, a deer, a rabbit, anything, um, food, water, shelter. If one of those is missing, they're not going to be there. They're not going to be able to survive. You have to have all three. So,
Yeah, they're not nice to haves. They're necessary.
right. So these four principles are what I think are necessary. They're essential. Leave one out or minimize one of them, and that's what's going to be holding your system back.
Yep. Good. David, do you have a question about Dr. Franzen's research?
Yeah, David Rourke. I farm 30 miles north of the Peace Gardens at Minto. Dr. Franzen was having an interview with no-till farmers, and the interviewer asked him a question about disturbance. They were originally talking about the getting a 50 pound per acre nitrogen credit for wheat if you've zero tilled for, I think it was 6 years.
Yep.
And the interviewer asked her, what do you mean by no till or zero till? And Franzen said that certainly low disturbance disc drill, that's definitely zero till. He said a narrow point hoe drill, like a Seedmaster, Seed Hawk, that would be a zero till. But he also said that as long as you don't go more than 2 inches deep with a complete sweep, kind of like a Concord direct seeding, that could also be zero till. And I called him after that and I asked him how did you measure that? And it was observation, and he did measure microbial activity. And um, we are faced with herbicide resistance and stuff, and sometimes some disturbance or a cultivator can get those weeds. So is there um, how much disturbance is too much, I guess?
When I worked for Natural Resources Conservation Service, there was a part, a tool that was part of erosion prediction, and it was described as the soil tillage intensity rating, STIR, STIR. And what I realized as I looked at all of these systems, the ones that were making significant progress in restoring, improving soil health were those that in a given year had no higher STIR rating than 20. And that number is just an index. There's really no units to it. But if someone did more disturbance than what would be a STIR of 20, then things just didn't progress. They either progressed very slowly or they didn't progress, or they went backwards from my, observations. And a stir of 20, an example of that would be one pass with a hole opener drill that had maybe a 4 or 5 or 6 inch sweep on it. And then, it's also a function of how fast you're going. As the faster you go, the more soil is going to go flying. Is going to get disturbed and go flying. So that was just my observation. I've never seen any research done on that, but that's how I would answer that question. And so the ones that were using a single disc opener drill, I noticed made progress the fastest. And the ones that had just the shank opener that was, wasn't very wide at all. Those are what, 1.5 inches or something, were close behind those folks as far as how quickly they were improving soil health. So when I say minimize disturbance, yeah, I'd love to see everybody just use a disc opener drill and that would be it. But if for some reason you have to use tillage to deal with a weed, or you were out there when it was wet, you made some ruts or things like that, then, deal with it, do it. But as long as you aren't doing that greater than 20 stir every year on a regular basis, you should be able to make progress on improving soil health.
I have another question, but I can ask it a little later if you want.
No, go ahead, David. Yeah, you're good.
I've been doing quite a few tests with I've got about 2,000 replicated plots on soil health from a perspective of adding cover crops, which sometimes is more difficult than I would like. We have anywhere from 1, 3, 6, and even full season covers in these trials. And then we have added biology, and they're usually, well, they're just seed treatments, like an Eco Tea or a Johnson Sioux or an earthworm extract. And I think we get some responses, but we listened to a guy by the name of Brian Zach, I think, the other day, and he had what I would call remarkable impact, having not to be able to use any nitrogen anymore. Whereas my trials there is some definite nitrogen credits that we're able to achieve, but it's certainly not being able to eliminate that nitrogen. So, what's your experience with adding biology and cover crops in terms of reducing nitrogen requirements?
The more diversity you can get in plants that you're growing out there, you mentioned the multi-species cover crops, you're feeding a greater diversity of plants feeds a greater diversity of organisms that live in the soil. And since the soil food web is very complex, it's very redundant, so that there's always somebody working all the time. When the soil is dry, it's this cadre of organisms. When it's wet, it's this cadre. They may do almost the same thing, but just under different conditions. So I look at if I can support and feed the greatest diversity of organisms in the soil, you can get to the point where nitrogen is not an issue anymore. I used to work at the Dickinson Research Extension Center in western North Dakota. And they had a study there where they did no-till, and they had, I don't remember now how many cash crops, half a dozen cash crops, and 2 or 3 different cover crop mixes. So they had quite a diversity of plants involved, and disc opener drill, zero tillage. Part of the protocol of that study was to apply nitrogen to meet, I believe it was a 40 bushel spring wheat yield. And when they got to about the 6th or 7th year, their soil testing showed that there did not call for any nitrogen. So they stopped applying nitrogen fertilizer, and they continued to still get the yields that they used to get applying the fertilizer. So they've basically got to the point where they don't need nitrogen fertilizer. So, I think you can certainly get there if you have enough diversity. Um, as far as the biologicals, I see the biggest response on the most degraded soil, and that shouldn't be a surprise. The most degraded soils have the least amount of biology present, usually, if you do PLFA or some other analysis. Usually you see very limited diversity of organisms in the soil. So if you have a very degraded situation and you add some biology that wasn't there, and you manage the whole thing to foster that, then you'll see a pretty positive response. If you already have a soil that's functioning pretty good, has a pretty good soil microbiome, and you add something else to it, you might not see much of a response because your biology is already there. So that's that's how I look at those things as a tool to take you from a situation where you have very little biology and help you climb the ladder of building that soil microbiome back. As long as you're managing the soil to be favorable habitat, you should continue to make progress. So I don't know if that answers your question or
Yeah, that's good. Thank you.
okay.
John, there's a question in the chat from Clinton. He's asking 15 part per million FOS inhibiting the mycorrhizal fungi was mentioned in your book.
Mm-hmm.
Have you seen other synthetic nutrients that negatively affect mycorrhizal fungi or other biology?
Not that I can say other than nitrogen. Um, if you apply, too much nitrogen, and when I say too much, and I don't have research, this is just my observations. When I see systems that are applying 50 pounds of actual N per acre at a given application, it seems like the plants then will take advantage of that and use that instead of associating with the soil microbiome. And then when that's gone, whether the plants use it up or it leaches or volatilizes, whatever, when that's gone, then the plants have to start to build those relationships again. And for annual plants, sometimes that happens in the middle of the season when these plants should be filling grain, should be making seed. And if they have to spend their resources, their sugars, to make these associations to get what they need that late in the season. Sometimes we shoot ourselves in the foot by having put that nitrogen out there. But so I've seen where there's an excess of nitrogen inhibit mycorrhizal fungi and inhibit rhizobia infecting pea or other legumes. And nitrogen, just in a general sense, it for lack of a better word, it distracts the plants. It distracts them from associating with the soil microbiome and just uses the easy supply of nitrogen in whatever form, is usually nitrate or something like that. And the soil microbiome is left unfed for a while, and that causes problems as you go through the season.
What you're saying is it's almost like a feast and famine situation. That's makes it pretty hard for that annual plant to kind of consistently access nutrient if it's not there from us feeding it.
Right. If it doesn't have to spend its money, its sugar,
Right.
associating with the soil microbiome, because the nitrogen is laying right there and right in there by the roots, then it won't. But when that's gone, then it has to go back to doing it the old-fashioned way, the way it should have from the start. And yeah, that can mess things up, especially for annual plants.
Any other questions? Clinton, did that answer your question?
Yeah. No, that definitely does.
Okay, good.
And getting back to that, I just made a note here what you said earlier about the simple versus complex forms of nutrients. Dr. White's work with rhizophagy, where he's been able to observe that, where plants literally take in bacteria, typically, but sometimes algae, literally take in the whole organism and will strip it of most of its nutrients, to simplify it. And then the genetic material will be ejected back out through plant root hair, back out into the soil to basically reform itself. And, then it may or may not be pulled into the plant again. But if plants have to get their nitrogen in the form of nitrates, for example, they have to spend a lot of energy and a lot of water to work with that, to then build that into an amino acid, a protein, some other tissue, some other compound that they need to function. So if they can get something that is more ready-made, so to speak, if they can pull a bacteria in and take amino acids from that bacteria, well, now they already have an amino acid. It just saved them a bunch of water, a bunch of energy, etc., that they would have had to have used to make that amino acid themselves. And it's in this way that these plants can move along in their process of building all the things that they build, the higher molecular weight compounds, the phytonutrients, etc., that they need. They can be more efficient at making those things than they could by using, for example, nitrate nitrogen out of the soil. So that's where the whole nutrient density thing comes in, and just the general efficiency of how these plants can function. The other point you brought up earlier about growing soil. Years ago, NRCS had a big poster that showed it takes 500 years, I think is the number they used, to build an inch of soil. And so the poster had all these dates in human history that went back 500 years. And that's how long it took to build soil. And whenever I saw those posters in our field offices or other places, if no one else was around, I was taking those down and throwing them away because it was hopeless. As a producer, I look at that poster and 500 years. Why should I even bother? How am I going to know if what I'm doing, somebody's going to keep doing what I'm doing for 500 years to make that inch of soil back? So it wasn't, and with regenerative ag, we're not talking about forming soil. Forming soil from parent material takes thousands of years. You're leaching clays, you're doing all this stuff that plants and organisms carry out. Yeah, it takes a long time to form all the horizons in a soil, etc. But what we're talking about with regenerative ag is restoring the capacity of the soil to function. Just trying to get it to function again, not completely try and reform a whole soil profile. So those are two different things. And you can get, depending on how committed you are, you can get a pretty degraded soil to function to the point of, well, like Dr. Franzen's research, 5 years to cycle 50 pounds of nitrogen again. So it doesn't take that long. You have to take a leap of faith in the first 3 years because there's not a whole lot changing. It doesn't change very fast. But once that biology starts to come back, it starts to increase exponentially. And so you get past the 3rd year, the 4th year, the 5th year, and you're, hey, I'm starting to see nutrient cycling. I'm starting to see better aggregate stability, all these things that are pretty easy to observe. And once you get to year 7, 8, 10, you start to see things getting better and better if you have enough diversity in the plants you're growing. So yeah, there's a big difference between regenerating, restoring the capacity of the soil to function and actually trying to build a whole new soil profile. Those are two different things.
Any other questions at this point, or we could move on to another topic?
As we mentioned aggregation here a
Yeah.
little bit, and when people ask me what my favorite soil health indicator is, and that's it's soil aggregation. Because if we have stable soil aggregates, that tells me that the organisms that make the glue that hold the aggregates together are doing so at a rate greater than the organisms that want to eat those glues are consuming them. Because it's a continuous process. You don't just make a soil aggregate and it's there forever. You know, you have to make a soil aggregate and it has to be maintained with glues that fungi and these other organisms make faster than other organisms are trying to eat those glues. So if you do a lot of tillage, a lot of disturbance, and you break those aggregates apart physically and introduce a lot of oxygen into the soil, there's bacteria that will consume those glues very quickly. And your aggregate stability will go backwards, it will fail. So aggregate stability integrates a lot of different things into one indicator, and that's why I like it. And it's also very easy to measure. You just take an aggregate, make sure it's dry, throw it in some water and see how long it holds together. If it falls apart in less than 3 minutes, it's not a very stable aggregate. If it holds together for more than 3 minutes, then it's pretty good, pretty stable. So it's a very good indicator because it tells me a lot, and it's a pretty simple indicator to assess. You don't need a lot of sophisticated equipment to do that. You can send soil samples into a lab and they'll do aggregate stability and give you a number, which is great. I mean, you can do it yourself too. It's a little more, you have to be a little more patient to mess with that, but you don't really need anything more sophisticated than a jar of water and a dry aggregate to get a pretty good idea of what's going on there.
Yeah, that and a shovel is all you really need, and you can pretty much over time uh, know if you're improving.
Yeah, just making those visual observations, they're all pretty simple and pretty inexpensive.
I have another question along that same line. Do you do any smell tests? Can you correlate that at all to soil health?
Yes, and I was just listening to, if any of you are familiar with John Kemp, um, he's actually an Amish farmer that has wrapped his mind around a lot of this stuff, and he actually has a company that sells biologicals. But I visited with him. I've been on his podcast and picked his brain on some things, but now I'm trying to remember where I was going with that.
Smell test.
Smell test. But that's one of the things that he mentions in just detecting the aroma of the soil, particularly actinomycetes, actinobacteria, that have that geosmin, that earthy smell. And one of the questions that came up in a little webinar that I was just watching was someone talking about growing potatoes, and that by planting and digging potatoes, there's a lot of soil disturbance, and wondering, what can I do to mitigate that, and so on and so forth. And John Kemp said, potatoes have the capacity. They're one of those crops that has the capacity to feed the soil tremendously. And it's unfortunate that there's so much disturbance that accompanies potato production. And I've been growing potatoes in my garden for many years without tillage. I just put the seed pieces on the soil surface and I cover them with mulch. Old alfalfa hay works the best. Carbon nitrogen ratio is about right. And the potatoes grow just fine. They root down into the soil and they form all of their tubers above the soil, between the soil and the mulch. So in the fall, once those vines senesce, I just go in there and push the residue aside and pick the potatoes up. And I get essentially the same yield that you would get doing it the traditional way of planting the seed pieces in the soil and then digging them up, which is a lot of work. So just laying the seed pieces on the surface, covering with mulch, and then coming back and throwing the mulch aside and picking the potatoes up is a lot easier, but it's also a lot better for the soil. Those potatoes foster actinobacteria, fungi, a lot of things. They put a lot of sugar, a lot of nutrients into feeding the soil microbiome. So if you can grow that crop without disturbing the soil, then you get to have your cake and eat it too, as far as you can use them to build soil health instead of maybe taking a step backward because of all the disturbance. So, but actinobacteria are one of them, the aroma, some of the saprophytic fungi that don't associate with plants, they just break down residues, are also another one that you can usually smell if they're present. So, yeah, unless the soil is really dry, usually the aroma is a pretty good indicator.
Yeah, I think what we've found is, unfortunately, a lot of especially our cropland soils, don't have much odor at all. Almost an absence of odor a lot of times. And I can't imagine that that's a good indicator of functioning soil biology.
At least some parts of the soil food web are not there.
Yeah.
Actinobacteria and saprophytic fungi, at least they're probably not there in any appreciable amount. Yeah. Earthworms are another one. Those earthworms reproduce based on their weight, not their age. So the faster they grow, the sooner they will be able to reproduce. So if you if you dig a hole, if you just put a spade in the soil and turn a good spade full of soil over, if you can find at least one earthworm, that's not bad. I like to see more in the neighborhood of 8 or 10, but the soil in my garden that I haven't tilled in 20 years now, if I, and I did once, my kids gave me a hard time about that. I dug a cubic foot of soil and actually counted all the earthworms. There were 75. And they gave me a hard time about that, saying, Dad, you're the only guy I know that would actually do something like that. But so I asked the soil biologist, soil microbiologist, okay, if I have 75 earthworms in a cubic foot of soil, and the soil is full of their burrows and their castings, how long would it take for them to eat all of that soil and turn it all into worm poop, worm casting? And they said probably about 4 years. So my soil, the upper 6 inches of it is basically all worm castings, or was at one point, which make pretty stable aggregates, and which is nice because I have a silty clay, silty clay soil that can be difficult without good aggregate stability and good porosity. A silty clay soil can be pretty difficult to deal with sometimes.
Thinking about that on that sort of topic, with a lot of our soils having poor aggregation, so not great pore space for air and water to move. What would you say would be like um, historic infiltration rates on native prairie versus infiltration rates on cropland today?
I haven't measured infiltration on rangeland very much, but on well managed rangeland that has a diversity of plants with robust root systems, um, it's not unusual to get 5, 6 inches an hour. Some of the better cropland soils that have been well managed, my garden is 7 to 10 inches an hour. So yeah, I've seen infiltration rates anywhere between 5 and 10 inches an hour on well managed grazing land, or cropland soils, which, if you think about that, it would have to rain pretty hard, pretty long to, rain more than 5 inches an hour.
Yeah, like the soil carbon sponge is pretty big in that case. But what do you
Well,
think what do you think is infiltration rate though on, say, like, I don't know, Midwest corn, soybean, or up here wheat, canola, um, even if it's no-tilled?
um, I would expect it to be at least a couple inches an hour. Um, because even on stuff, we had a soil health demonstration down in North Dakota that we started out with some very degraded soil. Water would run off those fields when we would get a quarter of an inch of rain that took all day to fall. So the infiltration on it was terrible. By the 8th year of that demonstration, we were doing no-till and diverse rotations and even a little bit of grazing. We were up to about 9 inches an hour. So on something that hasn't been tilled for a long time, even if it hasn't had very great um, crop diversity, I would still expect to see a couple inches an hour,
Yeah.
which is, usually enough that you're not going to have runoff, you're not going to have erosion, you're not going to have ponding, the issues the things that can be issues. Here where I'm at now in Red River Valley, was part of actually a small part of Glacial Lake Agassiz, which you guys have, the majority of that.
Yep.
And I see a lot of tile drainage in some of the soils that are silty clay loam, whatever. And because there's really not a lot of place for that water to go otherwise. But even where there is, and guys are doing some surface drainage to get the water to run off the field. But I was on a farm, and it was just north of Grand Forks somewhere. And the guy had tile drainage, and he showed me, where the tile drains all came together and went down into this legal drain, this ditch. And it was in the springtime, I would say early May, maybe late April. And the soil was not frozen anymore, but there was water standing in that field. And I asked him if that field was tile drained. And he said, well, yeah, it is. And then, he showed me the system. And I said, well, why is there water standing there? The soil's not frozen. The soil's not frozen, and you have tile drainage. That water's supposed to go down and go out the tile and get out of your way. Why isn't that happening? And I said, the reason it's not happening is you don't have any aggregate stability and no porosity to allow that water. So you spent a whole bunch of money on tile drainage. That's not working because the way you're managing the soil is not allowing that water to go down to the tile. So, soil health is important on all these situations. Even if it's your objective is to get the tile drainage to drain your fields so the water isn't sitting at the surface so you can get out there and plant. You got to have functioning soil to do that.
Yeah, that's a good point.
So what's going on in the soil and the soil microbiome is more complex than I think we'll ever be able to fully understand. But the principles are simple. The principles are easy to understand and apply, so that if we can create this favorable habitat for the life that's supposed to be in the soil, and then basically just get out of the way, it will do all these things for us. It will infiltrate and store water. It'll cycle nutrients. It'll feed our plants, etc. So, whether that's cropland or grazing land, I've seen some pretty bad soil health on grazing land. What was native rangeland, because it wasn't managed properly, and the roots of the plants just gave up, collapsed, receded, however you want to explain it, and the soil collapsed with it. And then your water infiltration suffers, and nutrient cycling suffers, and all those things. So you can screw up the soil without tilling it by mismanaging perennial plants in a grazing system. looking at my list to see. It was, I guess we talked about that stuff. Yeah, but on cropland, on cropland where folks have been doing no-till, reduce the disturbance. The biggest thing that I see holding them back now is crop rotation. If there's not enough diversity there, Dakota Lakes Research Farm in South Dakota, Dwayne Beck, you probably all heard of Dwayne Beck. His whole diversity index is an excellent tool to assess your crop rotation and see if you have a good level of diversity. And with his index, I believe if you have a diversity greater than 2, that's usually pretty decent. If you can get up to 3 or a little over 3, that's even better. And that's where, the rotation itself, plus anytime you're using a cover crop, to have as many species in that cover crop as you can to get the most, to feed the most diverse segments of the soil food web. So I kind of rambled on a lot of different things, but I certainly don't have the answers to everything.
Yeah. What would you say are some of the more successful intercrops? You have a couple listed there, oat pea and winter trit and hairy vetch are a couple of good ones.
Yeah. I've seen pea and canola work pretty well together. The winter triticale and hairy vetch was one that we were doing on the soil health demonstration at the Dickinson Research Extension Center. And if you have livestock, I like that one a lot because it produces a lot of biomass, whether you're going to hay it or graze it. And both those species, the triticale and the hairy vetch, are very they feed the soil in a tremendous way. They're living roots for a long period of time, and I used to think that the soil pretty much went dormant over winter, but if you have snow cover, there's a lot going on. There's a lot of biologic activity that goes on because that soil doesn't get that cold. It may be below 0 above the snow, but down below in the soil, that soil might be frozen a fair depth, but it's not that cold. There's still some biologic activity going on down there. I've seen residues decompose over winter that, there was pretty good residue there in the fall. Got snow cover, and you go out there in the spring, wow, half of this residue is gone. It decomposed under the snow during the winter or very quickly in the spring, or both. So yeah, if you have livestock, I like that one a lot. And usually if you have hairy vetch on a field, you're always going to have hairy vetch on a field, but not to the point where it's really becomes a problem. Because we had corn in the rotation with that, and And if you went out in the corn during the growing season, you could always find a little hairy vetch out there, but it didn't really affect, it didn't negatively affect the corn. So,
So maybe that's a good place to stop, see if there's any last questions, and maybe we could wrap up, talk real quick about where you think the soil health, regenerative movement's going, um, and if a producer's curious to get started, maybe how, if they're a grain farm or mixed farm or cattle farm, just a few things that they could. I think there's lots of regen curious producers. They're just unsure how to get started.
yeah, I think to educate yourself, whether that's reading books or listening to podcasts or visiting with producers that have been doing some of these things for a long time. Those are all good ways to educate yourself. When I wrote my book, I wanted it to be approachable yet fairly comprehensive. So even that, or reading some articles on just understanding what soil health is and what the principles are, so that you can wrap your mind around some of these things, and keep it simple. You can get really complicated, but to just look at these four principles and think about how you can apply all four of them simultaneously to some degree, or like I said earlier, maybe you're already applying a couple of them. You just need to apply or think about a couple more. So, and there's lots of arguments about, well, what's regenerative? And some people want to look at it like organic, where you have to have a certification and things like that. And there are Regenified is, if you're familiar with Gabe Brown, that's one that he's working with for folks that, if you do want some kind of a certification, but it can be as simple as just seeing if your soil health is improving. Follow these principles and see, is water infiltration getting better? My aggregate's getting more stable. Then you're regenerative. You're rebuilding the soil. It doesn't have to be any more complicated than that. So you can go down a lot of rabbit holes and get into some things that can be very helpful, very informative, but you don't have to if you don't have the time or you don't want to. I do, because I talk about this stuff all the time. But and as far as regenerative movement, it's moving. I'd like to see it moving faster. I'm working on another book right now that's kind of focuses on that. What soil health is, what regenerative ag is, and how we can get it moving so that it's more mainstream and not, because as I look around the country, boy, I see a lot of soil that's degraded and continues to be degraded, and that's not good. I mean, just, you don't have to care about the environment or anything else, just care about staying in business. Trying to farm dysfunctional soil and supply all the inputs, I don't see how that could pencil out for very long. Um, so that's why I'm, in this game and trying to teach people these things is, yeah, I'd like to see the soil restored, but I'd also like to see the farmers stay in business. Um,
Yeah.
to be out there to continue to restore it.
Yeah, that's great. Any last questions, comments? Well,
It's
thanks.
nice to
Thanks so
see. It's nice to see the interest, and I would say you guys keep thinking, keep sharing things with each other, and I don't know, I've learned
Yeah.
more. I've learned more from farmers than I have from anybody else. So
Yeah. Yeah, the regenerative community up in Manitoba, Saskatchewan is growing quickly. I think it's fastest growing segment of prairie agriculture. So it's happening. It's always, of course, like you say, quicker is better, but no, it's definitely growing. Producers are understanding soil more deeply, and that's making their farms better, more profitable. So yeah, it's great. And that's of course why we had you on, because um that's what you've been writing and talking about. So we appreciate that, and thank you very much. I'm gonna record this. I recorded it, and so we'll get it out to everyone so you can rewatch it. And uh, thanks a lot, John. Appreciate your time.
yeah, thank you. It's always fun to share with people that are interested in this.
Yeah, it is. All right. Bye.